In this section of 7.3, we're given a vector's magnitude and the angle from the x-axis along with what quadrant it's in, and we're asked to find the horizontal and vertical components for each vector and write that in component form. So that we can use the formulas that were given to us on page 346. We also derived those formulas from the making a right triangle with the x-axis. So for this one, our magnitude is 12, so we're given that magnitude is 12, so the length of that line is 12. And our angle is 25 degrees with the x-axis. And since it's in quadrant 2, that tells us that, let's see, so we need to figure out what this angle is. Which we can find from, it's 25 degrees short of 180 degrees. So that's 180 degrees minus 25 degrees, which gives me 155 degrees. Okay, so my theta, so this is actually theta r. Keep that green. So the 25 degrees, it gives me the reference angle, which I could use if I look at the quadrant and the reference angle. So actually I'm going to do this two different ways. So one way you could solve this problem, you don't have to do both ways, I just want to demonstrate both. So in green, we'll do it with the reference angle. So if I use the reference angle for this formula, then the only thing I need to worry about is changing the sign. So I could write A is equal to magnitude of cosine of theta of r, and B equals the magnitude of theta times sine of theta r. So the component would be between the two brackets like that. The A is 12 cosine 25 degrees, and the B is 12 cosine, sine 25 degrees. And noting that it's in quadrant 2 tells me the x will be negative, so that would be negative there. That's the exact value. And if I use a calculator, then I will find the approximate values just by evaluating that, and I get so that's one solution. Another way to find the same solution is using that purple angle. I got the 155, so if I use the position angle, then I don't have to think about the quadrant anymore. And I don't have to change the sign. So A equals V cosine theta, B equals sine theta. So my component form is 12 cosine 155 and 12 sine 155, and I'll get the same results, except this time I don't have to use the sine, because since I'm taking the cosine of 155, I will get a negative number. So when I put this into the calculator, I get 12 times cosine of 155. Oops, I get negative 10.9, and in the green one I also got a negative, but I had to put that negative in manually by thinking about the quadrant. Whereas if I use the position, that purple position angle, then the sign is already given to me by the angle. And then I do 12, for the B, the vertical component, I do 12 times sine of 155, which would be So I get the same answer either way. Either using the quadrant to give me the sign or using the position angle to give me the sign.